Alright, so we've made it to the element of color. My personal favorite element. Let me go ahead and zoom in on the definition here. Definition is hue, saturation, and value. You can talk about any color in those terms. And there's a lot about color. Color theory further explains the element of color in great detail. And we're going to go into color theory today in this video. Okay, so what I'd like to do is to ask you a question, and that is, where does color come from? We see a lot of color in the world, a lot of different colors. Where does it come from? Okay, so let's get into that. Color theory. Okay. First of all color comes from light. If there's no light, there's no color, right? If you go into your closet, let's say at nighttime, close the door, absolutely no light's going to get in there. You don't see any colors. You know, you can feel the blue jeans and know they're blue, but if there's no light, there's no blue. Okay, so you need light for color. Okay, next, all the colors that you see in the world of objects, you know, a flower, a bottle of water, a cereal box, those objects, all of those colors you see from white light. If you just had, let's say, a blue light, everything would look blue, different shades of blue. But you need white light to see all the different colors of objects. Okay? If you're looking at Christmas lights and you're just looking at the light itself, well, you don't need white light for that. But for objects, you need white light to see all the various colors. And that's all of the colors. Pretty amazing. If you look around, if you see a flag, the red on that flag, that comes from white light. And this white light's not perfect. It could be from the sun, kind of a goldish white or off-white, but white light is what you need. Okay. The other two main things you need to know about color theory that I'm going to go over are the additive process and the subtractive process. You're going to need to know about RGB. That has to do with the additive process, and that stands for, the R stands for red, the G stands for green, and the B stands for blue. Okay, and that's talking about colors of light. The subtractive process talks about objects. Okay, so subtractive process, that has to do with CMY. The C stands for cyan, which is like a sky blue color. Magenta, which is like a hot pink. And then yellow. Everybody knows good old yellow. Okay, I'm going to get into these now. That's color theory. I'm going to start with the subtractive process here. What do we know about subtraction? You take something away, right? Actually, I will start with the additive process, then go to the subtractive process. Okay, so we got a color wheel here. I'll get to that in a second. But look at all these colors. These are objects. It's not light itself. We can see all. Why? The question is, why can we see all these colors? Well, there's white lights up on the ceiling, and so that's why we can see all the different colors here. It's just white light, and that's why we can see them. Okay, so here's what I'd like to do. I have some friends that are going to help us understand the additive process. Okay? And I like to call them the three amigos. And here they are. Three geckos. We've got a red gecko, green gecko, and a blue gecko. Okay? Well, why are we seeing these? Why is this red gecko red? Okay, and why do we see all three different colors? Yeah, we see it because of the white light up there, up on the ceiling in my classroom. Okay, so I'm going to explain that a little bit. Here we go. we've got this represents the white light from the ceiling that comes down, and you can think of this white light being made up of red, green, and blue light. That's the RGB, right? From right here. RGB, red, green, and blue light. Okay? They're kind of the same. Red, green, and blue light together is white light. Okay? But here's what happens. And by the way, that's the additive process. Adding 3 colors of light, that's the additive process, and that's light. White light. Okay? So it comes down. Now, the subtractive process happens. Okay? So again, you can think of this white light as red, green, blue light. Here's what happens, the subtractive process. This red skin right here, it's going to subtract or eat these 2 colors. All right, one at a time here. We got chomp, chomp, chomp. And it also eats the green, or subtracts the green light. Chomp, chomp, chomp. Okay? And all that's left is the red light. Okay? It doesn't subtract the red light. What it does is it reflects the red light into your eye. So that's why you see this red gecko red. And so this is actually happening. I have the white light on the ceiling. This is an object. The color actually is object that was from a pen. So that ink is a real object. It's not light itself. So that red light reflected the red ink, reflected the red light out of that white light. And it ate, ooh, there it is, the blue and the green light. Okay? So that's for red. Well, what happens with the green gecko, the second Amigo? Well, white light comes in. The white light is made of RGB lights. Okay? But now this time, this has a different property of the ink, the green ink or the green gecko here. So now, what it's going to do is it's going to eat or subtract the red and green light. That's just a property of the green skin or the green ink on the paper there. Okay, so here we go. Crunch, crunch, crunch. And all we're left with is the green light. It doesn't eat it. It doesn't like to eat it. It doesn't taste good. It reflects it, right? And that's why we see this green, and the green light goes into our eyes. Okay? All right, last one real quick. So the question is, why is the blue gecko blue? Well, once again, white light comes in from the ceiling up there, made of RGB lights. And this time, it likes to eat, tastes good, the red and the green light. Now he really likes this one. Munch, munch, munch. And the blue light, oh, it doesn't like the blue light, so it reflects it into our eye, and that's why we see it blue. Okay? So that's the subtractive process and the additive process, really. Okay? And so that's specifically how we see color in terms of light and color theory. And that's how we see all the colors. Okay? All right, you might want to think about, well, what about orange? Well, it doesn't eat all of the... orange would not subtract all of the red light. It would reflect some red light and some green light. And so different percentages give you all the millions of colors that we see from objects. But this is just kind of simplified. Okay?